students, let us start our new session of chapter 14, Semiconductor Electronics, Materials, Devices and Simple Circuits. As we have seen, a diode can utilize as a rectification component or rectification device to rectify AC signal. How it can be utilized? Basically, the diode can conduct the current only in one direction from P side to N side in forward bias condition. This property we are utilizing here for the rectification purpose. So here, as you can see in the diagram, the alternating voltage available for us from the mains, which is 230 volt 50 Hz supply. This large amount of AC voltage cannot be provided to diode directly. So for that, first thing that we need to utilize the transformer which can step down the input voltage. So here we are using step down transformer to convert 230 volt AC into low value of the AC voltage. So here this alternating voltage we can apply across the diode in series with load voltage, and that pulsating voltage, that output we are taking across the load, across the resistance during each half cycle of the input. Here the property to rectify the alternating voltage using the circuit which is known as rectifier. So here that you can see in the diagram the circuit which is known as half wave rectifier. Here the secondary winding of the transformer from which we are able to get desired AC voltage across point A and B. Now A point is connected with P type of the diode and N type of the diode via load resistor connected with the B point. Now, when positive half cycle is given to the input, the A point can define as a positive and B point can work as a negative. So here, P type of the diode is connected with positive terminal and N type of the diode is connected with negative terminal. So diode come across in forward bias condition. So diode allowed to flow the current through the circuit, and across from the resistor, when the current can flow, the voltage drop can available, which we are taking as our output voltage. Now when negative half cycle is given, so here in the diagram B you can see the waveform. Positive half cycle is given as the input. So during this half cycle across the load resistor we able to get output voltage. Now when the negative half cycle is given as the input, point A is defined as negative terminal and point B is defined as positive terminal. So P type of the diode is connected with negative terminal and N type of the diode is connected with the positive terminal, which gives reverse bias condition. And as we know, in reverse bias condition, diode act as open circuit and current won't flow. If the current is not able to flow through the circuit, through the resistor, then voltage drop is not available. So across the resistor, no voltage drop would be there. It can consider as a 0 in the diagram B. Here in the reverse condition, the reverse saturation current of the diode can be available, which is very negligible in terms of microampere, and we cannot focusing in application purpose. So the reverse breakdown voltage of the diode should be sufficient larger than the maximum value of the input voltage at the secondary winding, so the transformer can protect the diode from the breakdown condition. So here in the next positive half cycle, again we will get the diode in forward bias and output voltage will appear. So the output voltage is varying or rectified only in one direction. So we can say that we are getting output only in half cycle of the input and negative half cycle of the input where output would be 0. So here we are getting rectified output. Here only half cycle of the input is utilized. That's why it's known as half wave rectifier. Now, this generated output, as we can see, is not pure AC, not pure DC. So that's why that output is known as pulsating DC. Here, its efficiency is very much low, as only half of the input can be utilized and the remaining half of the input voltage is going to be wastage in a reverse bias condition. So, to utilize both half cycle of the input, we are redesigning the rectifier circuit, which is known as full wave rectifier, in which instead of the one diode, we are using two diodes. So here, as you can see in the diagram, the output of the rectified voltage is available during both positive and negative half cycle, which is known as full wave rectifier. Here, whatever the transformer is there, it's a secondary winding having 3 terminals, positive, negative, and at the center, the terminal can be defined as a neutral. So that's why, based on the utilization of center tap transformer, this full wave rectifier is known as full wave. Based on the full center tap transformer, this full wave rectifier is known as center tap rectifier. Now here, while the positive half cycle is given as the input, the diode D1, it's a P side, is connected with a positive terminal and point B can behave as a negative. So here, P side of both the diodes are connected at the end of the transformer and N side of the diodes are together connected with the load resistance where the output can be measured, and the another point of the resistor is connected at center point of the transformer. So here, while the positive half cycle is given, A point is positive, B point is negative, and center point would be 0. So as we can see that diode D1 P type is connected with positive, diode D1 N type is connected via resistor to the 0, and 0 is negative compared to the positive terminal A. That's why diode D1 come across in forward bias condition. For diode D2, P type is connected with negative terminal at point B and N type is connected at a neutral point 0, and 0 is in comparison positive than negative voltage. That's why diode D2 come across in reverse bias condition. So while the positive half cycle is given to the input, only diode D1 will conduct and output voltage we able to get it, as we can see in the graph in diagram C. Now, as the negative half cycle is given as the input, point A become negative, point B become positive. So diode D1 come across in reverse bias condition and D2 will be in forward bias condition. So during the negative half cycle of the input, the current conduction is possible due to diode D2. So during the any one half cycle, only one diode is in a forward bias and another diode will remain in reverse bias. So here the current conduction takes place at a time only due to one diode. And while the current is flowing through the load resistance in both the half cycle, the current direction is remains same, and that's why the voltage across that diode is always remains in positive half cycle. So here, as you can see in the diagram, during the positive half cycle, the output voltage is available due to diode D1, and during the negative half cycle, the voltage is available due to diode D2. So here both the half cycle of the input is utilized to generate the output voltage across the resistor. So here this is a more efficient rectified voltage than the half wave rectifier. But here only half of the transformer winding can be utilized. So transformer efficiency is reduced. So here other full wave rectifier also can be utilized, that is a bridge wave rectifier, in which instead of the center tap transformer we are using regular transformer, but here 4 diodes can be utilized in a bridge structure. So transformer is connected with the bridge structure of the diodes, and using them 2 diodes at a time will be on in forward biasing will conduct the current, which will generate more efficient output. So in the comparison of half wave rectifier, center tap rectifier and bridge wave rectifier is most efficient and widely used also currently in the market. So this is how the rectification process has been done. But here as you can see that in from this rectifier we are not able to get any steady DC voltage, but instead of the DC voltage we able to get pulsating DC response, and for that to filter out these ripples, these pulses, we are using capacitor parallel to the load resistance. So here as you can see in the diagram, with the rectifier we are connecting capacitor parallel to the load. So how it will work? Here this capacitor will work as a filter to remove that ripples, to remove that pulses of that generated output, and that's why this capacitor is known as filter. Now let us understand how this capacitor will work to filter out these ripples. When the voltage across the capacitor will increases, it start to charge. Now as the capacitor is in fully charged condition, which across that the maximum voltage can be available. So as you can see in the diagram B, as the output voltage is increased from 0 to maximum, capacitor across the voltage, as you can see over here, it will rising continuously. At the peak value of the voltage, capacitor gets fully charged. So the maximum voltage can be available in the output. Now, when there is no external load would be there, then capacitor will remain continuously in charge condition. If there is any load would be there, if it is available, then capacitor start to get discharged through this load and voltage start to get reduced. Now in next half cycle again the voltage start to get increased and capacitor start to get charged. But here you can see that while capacitor will discharge in first half from positive half cycle, discharging rate is very much less than charging rate. Discharging rate is almost 100 times lesser than the charging rate. So discharging process is very much slowly and voltage reduced by very small amount. Then next peak of the output voltage when it is generated, then by that reduced amount capacitor again start to get charged and it will get fully charged and the maximum output is available across it. So this is how you can see that during the capacitor charging and discharging condition, almost constant output voltage we able to get it using the full wave rectifier and the DC voltage can be obtained. Here the rate to fall down the voltage across the capacitor depends on the product of capacitor and resistance. So that is RC, the product of R and C, that is RC, which is known as a time constant to fall down the voltage across the capacitor. So this time constant is depending on the value of C. So while the capacitor value is larger, then time constant is larger. It means it takes longer time to reduce the voltage, and almost at the output side maximum constant voltage can be available. So capacitor can use as a filter with the large value of the capacitor. Output voltage can be obtained using capacitor input filter near to the peak voltage of the rectified output. So this filter with this rectifier with the filter is most widely used in power supply to convert AC into DC. Here we are going to end the session. Hope you understood. Thank you.